work on the CPython article, and I'm not 100% sure of what I'm gonna do exactly because there's a lot going on in my mind. So I think I'm just gonna figure out, it's probably gonna take more time than just today to finish the article because there's a lot of stuff to think about. So I think I'm gonna go over the like flowchart that I did here. So I'm gonna continue to, first I'm gonna go over this flowchart. It's massive, and all these spots here on this, I think it's kind of like pink color. I'm not really sure what color this is, but all of these spots are nodes that I didn't complete because there's a lot of other codes. And then like this is the downside of doing this manually because I don't know how the thing is going to expand. So it's very hard to think about how to draw each thing. But I'm thinking about creating other parts of this graph and starting from the beginning from these nodes here. But I'm not really sure if I'm going to do that. So I think what I'm going to do first today is just going to walk through this thing here and look at the source code as I walk through that and try to explain roughly what's going on. And I still don't understand 100%. This is the part that I'm trying to clarify. The jump from the beginning where it initializes everything and then it transforms the file input into tokens. I still haven't figured that out. But then after I go over this, then I'm gonna continue to read this again. I already read one time, but it's very good to read this to clarify how it works. So basically, the way that it works in Python is that they have a couple of files, and then they have a whole program that they wrote in Python that uses that file, which is the grammar, to generate a parse tree. So the code in Python reads the grammar from a file, and then it creates all the code that is going to create the parse tree. So it creates the C files with the code that generates a parse tree. And before, the way that used to work is with LL1 parser, which is a kind of parser that uses one look ahead. So what they mean when they say one look ahead is just the amount of tokens that it's reading to make decisions. So it's like you can imagine that you have a string that is going to be the start input, and then the parser reads the string one by one. And then based on that, it makes decisions of how it's going to create the abstract syntax tree from that, or the parse tree. And Python used to work with this one, and then they moved to PAG, which is parsing expression grammar. And the difference between the two is that on this LL1, you can have ambiguity, which means that you can have different rules at any point, and then the parser can choose between any of those rules. So it's ambiguous because there can be multiple different options for each stage of the process where it's creating the parse tree. But the PAG is more deterministic because it's always going to select the first rule that it encounters and then move on to the other ones. So it creates something that is called a deterministic finite automaton, which is just a fancy way to say a graph that represents how one string becomes another string in a deterministic way. So you always have the starting string, which is the input you want to parse. Then from that input, you are going to read the string in a certain way. And then based on that way, and based on the rules you have, you're going to break down that string into other smaller strings until you reach something that is called a terminal, which is the syntax of the grammar that you have. So the different types of parsers are based on the rules and also in the amount of strings that it has to read to make a decision. And in the parser expression grammar, it reads an arbitrary number of tokens, which is of, I'm not really sure, I think it's tokens. So an arbitrary number of tokens until it makes a decision. That's one of the main differences between the PAG and the LL1 parser. And the other difference, I think, is this deterministic thing where the LL1 is more ambiguous and non-deterministic because you can have several different permutations, and PAG is more deterministic. But the thing that is kind of confusing to understand is exactly like how it works with the, once you have the code for the parser, how does that integrate with the other stuff? Because they say here in the documentation some part that the difference between Python and other programs, other compilers, is that difference between CPython and other compilers is that CPython, I just forgot what I was gonna say. Damn, completely forgot. Yeah, I don't remember. I'm gonna have to see. I'm gonna have to wait and see if I remember. Just like blank in my mind. There's a part in the documentation that they explain something. Like it was one of the main differences between CPython and the other compilers. I forgot. So I'm gonna have to read again to remember. It was just on my mind, and then I was saying it, and it's like blanked. It's weird. What was it saying? I forgot. So I guess I'm just gonna go over here. Let's see if I can remember. I think the more I try to remember, the least likely is gonna be that I remember. Yeah. So I guess I'm just gonna go over this stuff here. Hopefully I remember what I was gonna say in the middle. Or maybe I should read this stuff first, then I'll go over this thing here. What I was gonna say? And so here on the flow chart, I just did one possible option. So like there's several different ways to run Python, and I just did the one that I think is most common, which is my case, is when you're executing a file. I'm gonna have to find the functions again from the beginning. I'm still trying to remember what I was gonna say. It's crazy. So the beginning function is this one, then it goes here. It's not that interesting. In the very beginning there, I'm just gonna set up everything to run the environment. It's kind of confusing as well. And there's some functions here that I didn't uh, go over because, like I said, it's kind of hard to expand because I don't know like how big the functions are gonna be, and then it's hard to think about the space of the thing. So it starts here, and then there's a bunch of functions that are for configuration, which I think they changed the states of this struct here. And there's another one, which is the Python interpreter thing. This struct here. I think I'm gonna finish reading this stuff because I want to listen to some music as I go over this stuff. So probably what I'm gonna do is just take pictures of this and then write the articles like as I go and see each part. The tricky thing is that I'm not really sure, like because obviously I can just take a picture based on the size that I have here, so it's kind of hard to decide where to break the picture to talk about the things. I think I'm gonna read here because if I read, it's probably more likely that I'm gonna remember what I was gonna say before.
Guide to the parser hash. Abstract hash. The parser in Python is currently a PEG, parser expression grammar, parser. The first version of the parser used to be an LL1-based parser that was one of the oldest parts of Python implemented before it was replaced by PEP 617. In particular, both the current parser and the old LL1 parser are the output of a parser generator. This means that the way the parser is written is by feeding a description of the grammar of the Python language to a special program, the parser generator, which outputs the parser. The way the Python language is changed is therefore by modifying the grammar file, and developers rarely need to interact with the parser generator itself other than use it to generate the parser. How PEG parsers work. Hash. A PEG, parsing expression grammar, like the current one, differs from a context-free grammar.
So the way, one thing that is kind of confusing, and I think that's, it's confusing because the actual part of the code that generates the parse tree, which is the parser generator, is written in Python itself. So that's kind of confusing because like, how is it possible that the thing is written in Python and it's going to create the abstract syntax tree for Python? But the way that I think it happened is that first they were using this LL1 parser, which is just looks at one token at a time, and then, or one string input at a time, and then it makes decisions based on rules. And then with that, the compiler, they created the code for the new parser generator, which is the PEG. And that it is located on this folder here. The PEG generator, and I think they say on the documentation that it's all this code here, which I'm probably gonna study as well to understand how it works. I think this is the stuff that I'm mostly interested on now, is how this generator here works. And it is kind of confusing to understand like exactly how it works, but I think that the language that they use to describe the grammar is Backnose. Kind of hard to say. Backnose now for this thing here, and they use the extended version, I think. So this is a kind of language which is a meta language, and this part gets confusing also because there's a bunch of meta and stuff. So it's like you're writing a compiler to compile things. So that's the kind of the meta thing. So this is the file that has the rules, I think. And there's two different files for the rules. This is one of the files. So I think that this file is the meta grammar, which is the file that is used by the parser generator, which is all the code here. And then once this code uses this file to create this one, I think. And then this is the one that is used by the actual parser generator to create the abstract syntax tree. So the code from this project here creates the code for the C files that are going to have the functions that are responsible for parsing the Python code, which is this parser.c. And I think the pagan.c as well. And the part that I'm not 100% sure that I want to clarify is exactly in the beginning, how does the file become tokens? I think that's what I'm going to focus now. Because it says at some point in the documentation there that, I think this is the stuff that I was saying probably. So like in Python, I think, yeah, that's what I was going to say. So in most compilers, you get the string from the file inputs, and then you convert that directly into abstract syntax tree. But in Python, it gets the file input and then converts automatically to tokens. At least there's something that's like that on the documentation that they say, but it's kind of hard to understand how exactly does that happen. And it's not very well explained, I think, in the documentation. So I'm trying to clarify that. How does it take the file input and directly transforms everything into tokens? And then obviously the parser is going to use the tokens to build the parse tree and the abstract syntax tree. And then on the compile process, it takes the abstract syntax tree and transforms into a control flow graph, CVG, on the compile function. And then from the control flow graph, it generates the bytecode. So this part here, this function that they say is the beginning of transforming the abstract syntax tree into a control flow. But a lot of these functions I didn't explore because it's sad, like I said. So I'm not really sure if it's worth it to create another part of this graph in somewhere else here on the Scalidraw thing to expand on these functions. Let me just continue to read this, and then I'll put some music and go over the graph that I have there. Then I'm gonna start writing the article.
And that the way it is written more closely reflects how the parser will operate when parsing it. The fundamental technical difference is that the choice operator is ordered. This means that when writing rule A, B, C, a context-free grammar parser, like an LL1 parser, will generate constructions that given an input string will deduce which alternative, A, B, or C, must be expanded, while a peg parser will check if the first alternative succeeds and only if it fails, will it continue with the second or the third one in the order in which they are written. This makes the choice operator not commutative. Unlike LL1 parsers, peg-based parsers cannot be ambiguous. If a string parses, it is exactly one valid parse tree. This means that a peg-based parser cannot suffer from the ambiguity problems that can arise with LL1 parsers and with context-free grammars in general. Peg parsers are usually constructed as a recursive descent parser in which every rule in the grammar corresponds to a function in the program implementing the parser and the parsing expression. The expansion or definition of the rule represents the code in said function. Each parsing function conceptually takes an input string as its argument and yields one of the following results. A success result. This result indicates that the expression can be parsed by that rule and the function may optionally move forward or consume one or more characters of the input string supplied to it. A failure result, in which case no input is consumed. Notice that failure results do not imply that the program is in.
Another thing that they explain is that, that I read on the PAP, I think it's 617, PAP 617, which is the PAP the proposal that they changed the parsers. So there's a bunch of explanations there. And one thing that they say is that the parser is a push-down automaton. So it uses a push-down automaton. So what that means, like, it's just a fancy way to say that it uses a stack to make the decisions. So the way that I think it works on a high level, and I'm trying to clarify because this is the downside of all these videos that I watched, and the explanation here is that at least so far, I didn't find one that demonstrates on the actual example like how it works on practice. They just talk about the concept, so it's kind of hard to understand in practice how it works. But from the concept level, the way that it works is that you have the inputs, then you can think about the grammar as a structure of rules. And based on the input, which is the data, there's going to be something that reads the input, and then based on the rules, so it's like reading the input and then it's searching for the rules that the input is going to fit. And then based on that, it pushes tokens or string inputs into a stack. So that's what a push-down automaton is. It's just a fancy way to say that it's pushing and popping on the stack to make decisions. So it keeps going and pushing stuff on the stack until it fulfills a row, and then once it fulfills the row, it starts popping the stuff again, and that's how it builds the tree, I think. It's just reading the stuff, pushing on the stack, and popping, and then based on the push and pop operations that creates like a graph that looks like a mountain, it generates the parse tree. I think that's how it works, but in practice, I'm not really sure. So I'm gonna have to study the code to understand, I think, this code here. And then in Python, all that code here uses this file which contains the rules. So the rules are written like this. And then you can have like, these are the different options that you can have. So like this is the rule, and then it's gonna check to see if the token or the string input fits this rule. If it doesn't, it's gonna go to the next one, the next one. And the first one that it matches is gonna take that. And then I think it pushes on the stack, but I'm not 100% sure. And then it continues to go, I think it goes on that broken down string and continues to go that way recursively until it reaches a terminal token. I think that's how it works, but I'm not 100% sure. So the entire goal is like you take a string, which is the starting input, and then you're going to transform into a bunch of strings that are terminal tokens. And the process of converging one to the other is based on the rules you have, which are the structure of the grammar. And that creates a tree data structure that represents the sentences that you have, I think. So obviously the reason why I'm very interested on that is because it seems to me that this is the most fundamental thing about all programming languages. And something that I was like, it's kind of confusing as well. I think this is one of the parts that I want to clarify as well, because it is very tricky. And I think that I've watched the Guido talk where he explains this stuff, and he says, like, you confirmed what I was thinking, that when it comes to this meta programming, which is what's happening here, the data is the code. So like they are the same thing at one level, because you have a program that is using the data, which is the actual commands, and transforming that into instructions. So it's like the data and the code are the same thing, But the thing that is kind of confusing is like when it comes to the memory, how does it work? And this is the stuff that I'm trying to clarify. Like exactly what are the fundamental differences between different programming languages? Because if you think about it, all of them are going to be compiled or boiled down into the same assembly instructions eventually. So the main differences between them have to be, which is something that I was thinking about yesterday. I found a Meta or Facebook project that they were trying to do a transcoder, which is something that gets code from older programming languages and converts to the modern programming languages. And obviously that's useful because then you can have legacy code bases that are automatically updated to the new ones. But they were using AI for that. And this is the stuff that I'm trying to clarify, which I think is the fundamental thing here that I have to clarify, which is why exactly is that a difficult thing to do? And I think it has to do with entropy, which is something that I saw, I think, on Solding Twitter, on a video he made as well. And it is something that I was also thinking about before, which is the difference between serializing a string or serializing data and parsing data. And he says that when you're serializing, like when you're putting a bunch of data on a file, you're increasing entropy because it doesn't take work for you to do that. But when you're parsing a file, it takes work to do it, and you are decreasing entropy because you're creating information. And I think that makes a lot of sense. But the thing is, like, the question is, why exactly can't you, like, why is it easier to go from a high-level language into assembly than to go from the assembly to the high-level language? I think that's the question that I want to clarify. And I think it has to do because of the nature of information. So this is directly correlated with the structure of the grammar itself, I think. But I want to see if it's possible to go from like assembly instructions into higher level languages. And if it isn't, like, why is that case? Because then you can imagine that if you have a Python code, for example, you can break down the Python code to assembly, and then like JavaScript is going to be essentially the same thing at the assembly level. So if you could take the assembly code and transform it to another language, then you can create this communication between different grammar. So like I wonder, and I think that there must be a reason why that's not possible. And from like a couple of places that I saw, I think it was on Stack Exchange or some site like that, that they were talking about some fundamental reasons why this is not possible. And it has to do with this whole thing about finite automata and deterministic or undeterministic behavior and the differences in grammars and how does that structure the language. And I think it has to do because of like the issue is that you can have an infinite amount of inputs because like there is no limitation on what kind of code you can write on any language. So the amount of inputs you can have is infinite, but the rules are finite. So I think that what's happening is that when you build instructions based on the grammar, you create information, and then from that point, it becomes very hard to undo that, let's say. I think that's the reason why, because the inputs are infinite. But I'm not really sure. I have to clarify this. I have to spend a lot of time thinking about this and then clarify the differences between the different grammars you can have.
Incorrect, nor do they necessarily mean that the parsing has failed. Since the choice operator is ordered, a failure very often merely indicates try the following option. A direct implementation of a peg parser as a recursive descent parser will present exponential time performance in the worst case, because peg parsers have infinite look-ahead. This means that they can consider an arbitrary number of tokens before deciding for a rule. Usually, peg parsers avoid this exponential time complexity with a technique called packrat parsing, which not only loads the entire program in memory before parsing it, but also allows the parser to backtrack arbitrarily. This is made efficient by memoizing the rules already matched for each position. The cost of the memoization cache is that the parser will naturally use more memory than a simple LL1 parser, which normally are table-based. Key idea is hash. Important. Don't try to reason about a peg grammar in the same way you would with an EBNF or context-free grammar. Peg is optimized to describe how input strings will be parsed, while context-free grammars are optimized to generate strings of the language they describe. In EBNF, to know if a given string is in the language, you need to do work to find out as it is not immediately obvious from the grammar. Alternatives are ordered. A, B is not the same as B. A, if a rule returns a failure, it doesn't mean that the parsing has failed. It just means try something else. By default, peg parsers run an exponential time, which can be optimized linear by using memoization. If parsing fails completely, no rule succeeds in parsing all the input text. The peg parser doesn't have a concept of where the syntax error is. Consequences of the ordered choice operator hash. Although peg may look like EBNF, its meaning is quite different. The fact that in peg parsers alternatives are ordered, which is at the core of how peg parsers work, has deep consequences, other than removing ambiguity. If a rule has two alternatives and the first of them succeeds, the second one is not attempted even if the caller rule fails to parse the rest of the input. Thus the parser is said to be eager. To illustrate this, consider the following two rules. In these examples, a token is an individual character. First underscore rule, A A second underscore rule. A. In a regular EBNF grammar, both rules specify the language. Triple A. But in PEG, one of these two rules accepts the string AAA but not the string AA. The other does the opposite. It accepts the string AA but not the string AAA. The rule A apostrophe vertical bar AA does not.
I think that this is the key probably. It has to do with like because the way that you construct a language is by placing meaning based on the rules. So the assembly instructions become higher level instructions based on the rules of the grammar, and that dictates the structure of the data structure of the grammar, which is going to be the tree. So I think that the degree to which you can translate one language to the other is going to be on how similar the data structures for the two different languages are. Because obviously if they're exactly the same, then you have the same information, so you can reconstruct the sentence. But if the tree data structure is different, then you're going to lose the meaning of the phrase because you're breaking down into assembly, and then when you're trying to reconstruct, you're not going to be able to say the same thing on the exact same way on the other language. So I think that the degree through which different programming languages are different is an exactly direct correlation with the difference in the grammars, on the rules of the grammars. So I think the fundamental key thing to try to understand here, what I'm going to try to do now, I think probably, is to try to clarify like what is this relationship of how does the rule of the grammar defines the tree data structure of the thing. So that's what I'm trying to do, I think now. And I think that's probably better to, but the thing is I'm not really sure because it might be very hard. So I have to spend some time thinking about like what is the best way to clarify this. Yeah, so I'm gonna draw some stuff here. Let me put some music, and I think I'm gonna follow the flow there. I'm gonna draw some first stuff to like show what I'm thinking about, and then after I do that, I'm gonna put some music, and then, or maybe I'll put some music now, and then I'll walk through this while looking at the code as well. It's gonna take some time. I think like this usually happens as well when I'm learning something new. It's like I'm on the phase that I'm kind of confused because there's overflow of information in my mind. So I need to like spend time thinking to clarify how everything relates to everything else. But maybe I'll just do it from scratch. Okay, I think what's happening is that I think this is like a fundamental thing even in normal languages. So it's not a property only for programming languages. I think every language is gonna be this way. Like fundamental thing from the universe. So what's happening here is that you're gonna have this impulse here, which is gonna be keywords. And then based on this, you're gonna have a machine that like reads the stuff. Then this is one of the differences is that like how the gradient for which you're gonna read tokens. So this is one fundamental thing, I think. So it can be like either like this, or you can read like only 2 words at a time. So this is one of the fundamental differences between languages, I think. And the amount of tokens you read to make a decision is gonna be directly correlated with the amount of terminal tokens you have, I think. Actually, not with the amount of terminal tokens, but with amount of connections, obviously, because if you're breaking down strings more frequently, then obviously you're gonna have a bigger tree, I think, because you're gonna have to connect all those different strings together to form the sentence. So I think that the size of this difference here is directly correlated with the amount of connections the data structure is gonna have. So like this is one thing. Then the other thing is the amount of rows. what would be the best way to represent this? The amount of rules for each stage, which are going to be based on whatever inputs you have here. Then it's going to search for the rules, and then based on the rules, it's going to move on to the other string. So, for example, this string would become something else here, like say just this one, after you apply this rule. And then from this string, let's say that the terminal, the actual syntax of the grammar is like this string here. It's like n. Let's say this is one terminal, so like you start with this one, then you move to this one, then finally you get to this one. And the tree data structure will be the connection of them. So, and this is what I mean, because like this is the process of creating the information, I think. Like the structure of this tree here is the information that is being created from the data. So the structure of the rules and the size of the tokens determine this tree data structure here, and this is the information that is created from the data. So the fundamental difference between programming languages is going to be the size of tokens that they decide to read and the amount of rules they have for each one. So if I think that what I have to do is understand how Python, like maybe not even Python, but the good thing about the Python one is that I have the code here. So I need to figure out if I can get this grammar for other languages and then understand how Python converts the grammar into the parse tree. Then once I have that, then I think I can test multiple different grammars. So the main thing that I want to know now, I want to study is the back however you say this stuff here. Backus null form. Because I think this is the main language to write the grammars. So this is what I want to understand. But let me go here. I should probably open the other thing here. Hey, mating, what's up, man?
Frightened of things that could happen. Might happen, might not happen.
So maybe this first part I go without the codes, and then when it gets to the parser thing, then I start reading the code again. So I think I'm gonna have to close all of these files here. And the way that they build is with this make file, which is another thing that is kind of confusing because I don't understand really well. But also, I copied this code for another project. I think what I'm gonna try to do is just like run the code directly to see if I can create the code for the parser by running this code on this file here. So maybe it's better to read the documentation to figure out like what exactly is the relationship between this one, and where is this other one used. I'm good, man. And you? There's also this other thing here that is another language that is used, and I don't remember really well. I think, yeah, this one is for creating the different types of nodes on the AST. So they use another language that is specialized for that. And these languages is like meta programming languages because they are languages that define how the code is gonna work. So I think that the main difference between programming languages is gonna be like the structure of the thing, the structure of the tree that the grammar rules create, and this structure is gonna be directly correlated with the memory management of the languages. And I think that's the reason why different programming languages are different. It's just the fundamental thing is the finite automata that they create. Okay, so this beginning just initialize everything. I have to see at what point does the first decision there true. I'm gonna close all these files, and I'll think about this later. So I think it's on the run main, the first branch that it creates. So it's this one. Yeah, this is the first one. So depending on the way you're running Python is gonna choose different things here. But I'm just gonna look at the run file. Also, I took some pictures. I think I'm gonna delete them. I'm just taking these pictures in case I lost the thing. I'll have to think about like how I'm gonna write this in the beginning. Following pictures show the flow of the execution of the function names and their location in the CPython class, blah blah blah. CPython. So the beginning, you just calls this function. Then I think that there's something related to the global interpreter lock here. To initialize this, I think one thing that I have to see is how does it change the main data structure there, which is going to be the Python interpreter. So the Python interpreter is a struct, and then based on these functions, I think it's going to change the data inside of the struct in the beginning. Mostly a bunch of configuration functions. And this one initializes the runtime environment, I think. And this stuff is related to the lock, I think. So it locks the thread, the main thread. And the question is, should I write about these functions? I think about whether or not it's worth it to write the article or to just go to the parts that I'm not sure about because I don't want to waste a bunch of time focusing on this first part that doesn't matter to me that much. I want to clarify how it works first, I think. And the part that is hard is like figuring out how the data changes in the beginning. Like based on the in doing this is the problem like with doing manually, but I still it's hard to think about a way to do it programmatically also. So ideally I would have something that keeps track of the data structure, then follows the execution of the thing and then highlights how the data changes on the main thing that I'm trying to. So for example, I have this one here, then I create the graph programmatically, and as the functions go, like I highlight how the data changes on the struct there. But I think doing manually is very hard.
Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing.
So I guess that this function allocates memory for runtime, as the name sounds. If it's 0, then it throws an error. Whatever. So maybe you should search here, like, I think all this part is just configuration stuff. I'm not really sure what to do, to be honest, because like I'm not really sure if it's gonna be a waste of time. One thing that I can do is just write down the struct that it has there in the beginning, the Python runtime and whatever, and then follow the execution here again, and then try to see how the data inside of the thing changes. But I'm not really sure if that's productive. Even this stuff here, I'm not really sure if it's good, because it feels like I need a lot more information. That's the problem. I think this is the main function that starts. I'm gonna go to this function. File lifecycle. That one is the main one that starts the environment, I think, or the interpreter. In the beginning to run the thing. So I think I'm gonna try to find the function that is like the bridge between the first initial configuration and the tokens. So maybe one thing that I can do is write what does this return. Just initializing this thread, state to null, and then this function probably creates, adds data to this thing here. So I guess like in the beginning initialize the interpreter state, then initialize the thread state inside of the interpreter state. Then inside of that function is probably gonna change the data of the whatever it asks there. This interp. So it's gonna be this thing here. Which is probably the one that it was initialized there in the beginning. So runtime is this one. This one was the one that was initialized here, I think. Yeah, so this function initializes the runtime, which is a global variable, I think, of this file. So it puts a bunch of data on this struct here, I think. And this is gonna be the main one, I think. So after it initializes that, yeah, this one initializes this one. Then it passes the. So this creates a. This gets the address. The thing is that in C, I remember that these two things are the same thing. So. Like in C++, this defines the address, the % here, and the other one is the pointer. But I think in C they are both pointers. So I think that this this creates a pointer to this variable here, but then this gets the actual value. So it makes this runtime equals to the value of this one, I think, but I'm not 100% sure. And then based on this function, is gonna initialize the thread state and it's gonna attach to this one, I think. And then probably on this one, it initializes the interpreter. The main one is gonna be this one, I think. So it checks to see if it's the main interpreter. And sets up global variables, apparently. And this one is probably the main one. So the question is, at what point does the file become tokens? Maybe it's this one, binary codes. I think this one's probably look interesting. There was something that related to standard inputs that is a string, but I don't remember it well. I think that these functions are just for, like, if you initialize a different type of input or a different type of file, your functions convert to UTF-8. It's kind of, I don't think that this is related probably with getting the tokens. Just probably converting different file formats to UTF-8. Also, I skipped all the functions related to memory because it was just gonna be too big, and the functions related to errors as well. I think these functions convert a byte file into UTF-8 maybe. So let me go back and search for other ones. On these functions, I remember that there's something related to standard inputs. So maybe these ones are the ones that, yeah. My life cycle instance. So we initialize a bunch of things, then I think here is probably these states, probably the thread state that initialized in the beginning there. That's the configuration. This functions here. But it doesn't seem like they are converting anything. It just seems like they are setting up some stuff that is gonna get the standard input from the file and then convert somewhere. Maybe what I can do is just try to paste the code on ChatGPT. I think that they create the file object probably. I'll be right back. I think once I understand, depending on how long it's gonna take, obviously, because I don't know, maybe it's like too much time, but once I understand at what moment does the file input becomes the tokens, I think I'm gonna go directly to the part that, to the other program that generates the parse tree. I think that's a lot more interesting to me. So, like, I need to study two main things. I think one is how the grammar works, like how the files of the grammar works, and then how does the code that translates that file into a parse tree works. And the most interesting thing is gonna be to create the graphs out of those, I think. Maybe the best way to figure this out is to go directly on the part that starts parsing or creating the tokens, and then seeing what structs is using to do that. And then I'll go back to this part and try to see at what moments does initialize the thing. So I think this is probably what is happening here. So it initializes whatever it's going to use for creating the tokens and the parser inside of a struct. And then based on these functions, it changes the data on that struct. And that's why I'm not... it's confusing to me because I'm not paying attention to the exact details of everything because there's too much going on. It should probably be this one. So I think these functions are for initializing the dictionary that is going to contain the modules, probably. So it's not related to the converting the files into tokens. But it's kind of confusing. There's like says here at some point. It's not this one, it's that one. Or this thing here. I think it's initializing this thing there. So it's setting the standard into the... It's creating the object and then setting the standard into this value here. So it creates this, which is probably another struct. I think this is a C function as well. Maybe should look at this. And so this is from the interpreter from the thread state. The thread state is inside of the this, I think. Yeah. So I think in the beginning there on the configurations, it probably creates a link to the thread state. It's gonna be one of these things. And this is the definition. Yeah, so it's gonna be the head probably of this one. And that's what the thing there is. So it's getting the configuration of the head, which is this thing. Then from this configuration it has this standard encoding, and then it creates this stuff here. The name I think is a standard input. I remember looking at this first time. But like the thing that is confusing is that I'm not really sure. I don't think that based on the code here, I think it's not related to transfer. I don't know the connection of this with the thing. I don't know if it's just a like it's part of the standard libraries or built-in libraries that get built in the beginning regardless of what happens. I think that that's most likely the case. So it's just building the sys libraries and then creating the object and making the library equal to that thing. And then these functions create this like a struct that is responsible for the standard input and standard output and standard error, and then they are connected to the configuration of the thread state, which is attached to the main interpreter state. So it's a linked list of threads, and then each thread initializes the configuration, and inside of the configuration initializes these libraries. So inside of the interpreter state initializes the sys libraries and the built-in libraries through that object there, but then it creates this standard input and standard output inside of the thread state. And maybe like the connection could be that this standard input and output is used to get the tokens, but I'm not really like I don't understand how this would be the case. That's the thing that I'm struggling here. It's difficult to know if it is related or not, because it doesn't make sense. Because I guess maybe I should try to print there. I remember that I built this at some point and then I could run to see, like when I put the print statements there to see what is going on. It's like maybe this is the way, because I have to understand what the input's gonna be. So like when I run the Python executable and then I put the name of the file, where is the name of the file going to be? Maybe I should go to the beginning there again. And then that's probably the way to try to understand this. So I think I remember looking at this, and I think that it's gonna be this thing. No, but this is an integer, so it has to be the argv, the name of the file. Is the second argument. So I guess one thing that I can do is just try to see. Oh, remember I wrote down the commands somewhere. I don't remember exactly where. As I knew I was gonna use. Which one was it? I think it was probably on the compilers, if it's not here. And now I don't remember where, but I remember I wrote down somewhere. It was on the desktop. I don't remember, obviously, I'm just gonna look at the documentation. I think it's PC/build, something like that. Yeah, maybe I deleted. I don't remember where I put. So I'm gonna have to try to figure out or find in the documentation again. It's here. I'm pretty sure I wrote this somewhere. Just this one. Oh, this one. I wanna see when I run what this argv is gonna be. I'm gonna test on a random Python file. Probably from here. Maybe this hello here. I wanna see where this what this is, and then maybe follow the execution again, trying to see what this thing becomes. So I wanna understand how the file input becomes tokens first. The main thing that I'm trying to figure out now. Once I figure this out, then I can go to the parser generator code, I think. Probably gonna read the documentation again. The documentation is kind of confusing, that's the thing. So argv is just hello world. So is the maybe not. No. Or is this number here? That doesn't make any sense. Let's modules main. Was inside of this config, and this is the configuration of this interpreter. I think this is the main one that initializes there. So I guess I just gonna write this down and then I try to follow the execution again. But the thing is that it's just so I guess the question is, how do I figure out where is initialized in the first place? This is going to be a number as well. So the question is, how does it know what the file name is in the beginning? There's nothing here. So it must be one of these functions here that I didn't look into. Not really sure though. It doesn't make any sense. Yeah, I think that it is gonna probably create a file object after this endpoint here that I print, because this is just a file name. So like the thing that it would make sense to me that in the beginning, somewhere in the configuration here, probably one of the functions that I didn't expand is calling the other function that sets up the name. And then after it sets up the name, at some point after this, when it starts running the thing, that's when it creates the file object. So like all this part here is not, it doesn't create the file object still, it's just setting up the main interpreter and the thread state and like all of that. And then once it goes through this part where it's actually going to start running, then it uses the file name at some point to create a file object and then extract everything. That's probably one of these functions here. It is one. It's probably this function here that runs. So I guess what I'm gonna do is try to see from these files here. I put this dot here on the ones that I didn't expand. So maybe the best thing to do is try to see if inside of these functions there is a call to the other one here. Because that's the only one that shows that file name there. Like this part here. And the weird thing is that this argv is just a number here, so like I guess this maybe is an address in memory. Config argv. We need to config. So it's probably here. Yeah, but it doesn't show there. So PyMain init. No, but it doesn't look like it is this one. It's just the same thing there, but yeah, it's a dead end. So maybe these ones. I think it has to be these ones here, probably. Have to do with the arguments. And so this is gonna be 0 in the beginning. So it's gonna go here. The arg v is the thing that is this number here. But I think that is not a number. It's probably this is the weird thing. Like it's harder on C because of that. Because sometimes like it shows a number, but it's just the address of the thing. So it could be a struct, but the problem is that obviously I can't see what it is. Maybe there is a way, but I just don't know. So I assume that it's probably something else, like a struct, or this a char, this data structure here. It has to be that, but like a string. So it's probably the string. I assume that it's probably the string with the path here, like whatever you pass, because it's the command line argument. So that's the only thing that makes sense to me. And then it's passing this config that initializes here. Trying to see if I can find the place that is going to initialize this run file name here on the config. And the args is this thing. Args. That's the same thing. Passes. So I don't think it's gonna be no. So it's just gonna be this one. So it passes there. Pre-initialize from config. I think it's this one. No. Reinitialize from pyarg v. This one is the beginning. Let me make sure that this is that n. Config rights. Oh no, there's more stuff here. I think both of them probably expand. think I'm gonna remove the camera and I'll turn on the light later on. It's getting dark here. Python says this function here. And it looks like doesn't do anything. I think probably here, maybe. By configuring it, import config. This one. Even it's import. What the fuck? No, this doesn't make any sense. I guess it's going to the wrong definition, maybe. Yeah. So I think this is probably the function that gets the path, gets the file name. Here is the same function that I've seen somewhere else that I don't remember. It's probably not here. I think I'm gonna put something else. Oh, here. So maybe it's this function. I think I found is this one. It's inside of this one, so it's on this path here. So it is like I was thinking about. So in this function here, it goes here, here, and then here. Then on this dot here that I didn't complete, it has this other function that creates a dictionary. And then inside of this one, it runs the macro, and then the macro initializes the file name, I think. It's this macro. It's probably what's happening. It's very confusing, to be honest. I think this creates a Python dictionary. Let's see what the macro does. But the thing is, like, what is this? I think, yeah, this is inside of one of the structs that initialized in the beginning, so like this pyconfig here is probably related to all these other functions here. Like, this is the challenge with this, like, it's kind of always like this as well. Like, so I have to think about how can I do it so that like, one thing that I was contemplating is that I don't need to execute the code to understand what it is, and that allows me to, like, it decreases the chances, it allows me to put get user input and decrease the chance that of hacks and exploits, because if I don't run the code, then obviously, like, I think that it makes it more less likely that their potential to be hacked there. So one thing that I was thinking about is that you can just create something that allows user input that converts the user input into abstract syntax tree or assembly versions that don't require me to run the code. So it's kind of hard to think about, like, what I need to do is to figure out how to get the data structure. But the thing is that the challenge is that the data structure is going to depend on the kind of program it is. So I guess the question is, how do I know what is the data structure that I want to keep track of? Like here, the part that is challenging is figuring out, is understanding how does the main structs that the program is using is changing over time, the data of the structs. And this is the problem with this flowchart, is that it doesn't capture that. So like here, I can see the connections of the functions, but it's still very confusing because I don't know which struct is being changed. So obviously here I'm assuming that all the functions are going to create this struct, and then that struct is going to have the data updated throughout all these functions here. And then that's creating the file name at some point. But it's still very annoying to figure out. So at some point inside of this struct is going to update the file name. And the question is where. That's the problem. But I think I'm not going to worry about that, to be honest, because it's probably a waste of time. As long as I understand the concept's probably better to just spend time trying to figure out the whole grammar thing, because I think the grammar thing is going to be more powerful and easier to implement first. Then once I figure out how to break down, because I want to figure out the easiest way to create a graph structure of the language, so I can find patterns on the languages after parsing the code. That's the main thing. And once I figure that out, then I can think I can focus on the other stuff later. So here I think I'm not going to spend time, but it would be better if I understood, obviously. And it's very hard to find, like there isn't anywhere explaining these things, I think. At least I couldn't find. But I assume that's what's happening here. So at some point, once it initializes, runs all these functions here to initialize the configurations inside of interpreter states or thread states. At some point, it assigns the file name to the argv. So it uses the argv, which is going to be a number here, but is probably address of this data structure here. And then assigns this run file name to that, whatever you pass. Like it's going to be this path here, I think. Yeah, unsigned shorts. It's very confusing. So where was I? Oh, maybe I should erase there and then put this stuff. So I think it's on this function by config init path. Okay. Yeah. This one. So I need to config. I forgot how did I got to that place. This wasn't here. It was here, I think. Very confusing. So I think it does all this stuff. So initialize these dictionaries and everything else, and then from the dictionaries it creates the values on the main config here that it passes to this one. Let me see, where does this on Python we need to config. It comes from this one. Config init imports. And then the one that it calls life cycle. Right. That's doesn't. Okay, so this is still this one. So initializes the config here based on the main interpreter, I think. So no, this is the interpreter from the thread state. So I think that what is happening is initializing the main interpreter. Initializes before on all these functions here. Then from that one it creates a thread, and then from the thread it has another interpreter. And then that's the interpreter that has the thing. And so here is a passing out thread state. Python lifecycle. So this one is the beginning one, but so this one, init core. This is the one that I think links the state, the thread state with the this runtime, which is this global interpreter. It's probably this one. Alright, so yeah, this one initializes the thread state, and it probably attaches to this main runtime state. And the interpreter is inside of the thread state. Yeah. So that's the connection. Let me. So I'm gonna write this down. So I have the like global by runtime. That has a thread state, and then from the thread state we have the interpreter. And then this has a config, I think. Runtime config.
If you think about particles, and it turns out that things like positions and velocities are not very precisely defined.
I think maybe I didn't write here. Like by init config. Init core. Yeah, I think I forgot or I didn't see. And this is probably the one that links them together. Or this one. Yeah, so the interpreter state is just this interpreter from the thread states. And then copies the configuration. It copies this config into this one, I think. So this is the main config, and then it copies to the... I don't understand why. but it seems like this is what's happening. So let me see if I think the first thing that it creates is the config. Then based on these functions here, it creates the thread state. And then it initializes the, like it links the thread state with this runtime. So the runtime is the main thing, then initialize the thread state. Then it has this interp, which is probably interpreter instead of the thread state. And then it links them together. It's very confusing. There's all these macros and functions. I think I'm kind of getting the general picture, but the nuances is gonna take a lot of time, I think, to understand. But hopefully, like the more times you look at it, the easier it's gonna get. It's just very confusing because there's a bunch of macros and a bunch of functions, then so I have to go back and forth to understand. Like how I want to clarify if that's how they are connected. So I think it's copying it's writing the config into the runtime, and this is the main config that is initialized there. I don't understand why they are initialized separately though. And then it copies this config as well on the interpreter config, which is inside of the thread state. So I guess it's just copying the same config to the runtime into the thread. That's what's happening. Neat standard out. Setting the mode to binary. So let me close all of these other files again. Try to start from the beginning. But I think I'm like starting to clarify a little bit. So like in the beginning, what happens is that it creates this pyconfig struct. Then initialize. The thing that is kind of confusing is like it seems to be like there are multiple runtimes. I think that the picture there, it makes it like a lot clearer, but I want to understand on the code how it works. It's kind of difficult to grasp because it's very confusing there. Fuck, where did I put this? Yeah, I think it's here. Oh, maybe it's here that I wrote down the commands. Yeah, this is the file. I knew that's I written or wrote down somewhere. Yeah, but I think this picture like makes it a lot easier to understand, but it's kind of hard to understand in the code there what's happening. So I think that this interpreted state is inside of the thread already, but like it's kind of maybe not actually, because yeah, this is the interp there that I saw in the code, and this is the T state that is the struct, and then this is connected to the runtime, I think, or the the thing is kind of confusing. It's like this is probably the runtime. Not really sure though. Like this runtime here. That's the part that is kind of, because there seems to be multiple of these ones. Like it creates one here, and then after it creates another one. Like on here, it calls this file, this function twice. One time here and then one time here. So I don't understand really well why though. But this one initializes the runtime, which is probably this thing. So maybe it's because there are several different interpreter states that you can have. But yeah. I don't understand really well. And it looks like this initializes the main config, and then it links the config with the thread, which links to the runtime. And then inside of the thread is gonna have the file name. So I think, yeah, it is initializing. It looks like it's calling like a bunch of times the same thing. So this is just the struct there. So maybe it's not initializing, it's just like several different instances, just reinitializing the same instance because this is the global variable. We only initialize once in the process, which aligns with the static initialization of the former globals now found in PyRuntime. Runtime should be initialized with every PyInitialize call, but doing so breaks the runtime. Time states and properly finalized currently. So I think that it just resets the state several times instead of initializing different ones. That's probably what is happening. Blah blah. And then once initialized, this is the one that's the configuration in the beginning. That it eventually becomes the other configuration through the copy function. I think this is the link here. Link a list that creates interpreted states. Yeah. I think I'm not gonna write the article like based on the flowchart anymore. Like I'm gonna have to spend a bunch more time to understand everything. I'm probably gonna have to like paste the structs and then go by like function by function, trying to see how the data changes. Or maybe it's just a waste of time and I should just focus on the other parts so I can try to create something that creates the graphs programmatically and then allows me to see how the data changes over time. So the question is like, how do I... but I think it's gonna take too much time because then I'm gonna have to figure out, like, there's several different steps. I think eventually I'm gonna be able to do it, but there's several different things that I have to do before that. Because this is obviously in C, it's probably better to focus on Python first. Then once I figure out the Python stuff, then maybe I can think about getting the grammar for C and building the graph for C and then figuring out how to parse everything. But I think what I'm gonna have to do probably is just like write down this struct somewhere and then I copy this on the scalar draw thing and then follow the execution again and see how the data changes. It's very confusing. So initialize one here and initializes this one. So here initialize another one. And the thing I don't understand is why though. Like, just initializing here should call this macro, but it doesn't make any sense to me. It's like I don't see the point of doing this. Here it's gonna reassign the value though. And it seems like it is only initializing here to check this thing here, but then like what's the point? When is this thing not gonna be... I guess it's because of this variable here. So maybe... Yeah, but when it... So I think after it initializes the first time, it hits this and then returns this instead of initializing again. So it just initializes once and that check, it calls there to see if it was initialized already. But then like, in what instance wouldn't it be initialized? That's what kind of doesn't make sense to me. But maybe it's just like one of this, like, just like for safe, like precaution or like something like that. Like, yeah, that's probably... So I think it only initializes one time, but it calls multiple times just to check to see if it was initialized or not. It's probably what's going on. So in the first time it makes this one and then it's gonna pass, it's gonna return okay on the next ones. Yeah, so that makes more sense, I think. Initialize this only once and then this one can have multiple different states here, I think. That's probably what's going on. Yeah, so initialize only once. Initialize once, and the other ones are for checking to see if it was initialized or not. So the first time initialize is here, the other ones are just to check, probably. Then the runtime. So I guess, let me see. There's nothing about the interpreter there, though. It's probably on this one. And initializes the interpreter. So in the beginning, just initialize the runtime environment, then initialize the configuration, and then on this function initializes the interpreter. It's just confusing as fuck to see like what is exactly the connection and the order that it connects one thing to the other. You should see the thread first, but I think that's like the thread is inside of this one, probably. Yeah, I think that's what's going on. So the runtime is the main one, but then like how does it initialize the? It doesn't make any sense here. So I need to figure out, because there is one more layer here, I think. So like it should be like this, and then the thread states and interpreter. but I'm not really sure where this part is. Maybe I'll stop streaming and then try to figure out off stream. I think I'm gonna try to use ChatGPT though to see if. Problem is like it's very confusing, so like probably gonna have to start from the beginning again, and then because the problem is that like once I go into the other files, I lose track of where I was because so many files. So like I have to think about a good way to ask ChatGPT, I guess. So this one, I think it initialize the main one, then initialize the config. The question is at what point does initialize the main interpreter inside of the runtime? I think it has to be here. It's like initializing a thread separately. Try to close everything. Then inside of this function, here. Not really sure. Maybe I forgot to draw that thing. So probably this one writes the config on the runtime, but then where does it start? So it's probably this one. I think it's probably this one. Yeah. And this is a struct. So I think that once it initializes the runtime, it initializes the struct automatically. And then on the other one, it makes the variable equals to the struct. Already lost the thing. Yeah, so when it initializes this thing, initializes the struct there with the interpreters. It initializes this. Then this function. And the mutex, I guess, is for the global interpreter lock. So if it's no, it's probably gonna lock the, yeah. So it locks the interpreter. So it's locking the main thread for the runtime, which is gonna be here. It's this struct here, and then it's probably setting this. I think I'll be right back. I'm gonna stay for another half an hour, then I'll stop. I'm not really sure how much time I'm gonna spend on this. Maybe I'll try to see if they have the Discord and try to find information there, or try to find other articles. Like based on the documentation there, I don't think that's. Maybe they do explain it, but I don't remember really well. So maybe I should go back and try to. Because there's a lot of videos and articles that they share there. So maybe there is some stuff that is helpful there, but I don't remember really well. Just trying to clarify the details of what exactly is going on. So I think I kind of understand it already, like on the conceptual level, but not well the nuances of the code. But maybe it's just a waste of time to spend or try to understand these details here, and I should go back. Should just go straight to the Python code that has the parser generator, which is probably what I'm gonna do next. I think next time that I stream, I separated the code into here as well. So I have the code here, this one. So I'm probably gonna copy the grammar files on this one and then try to generate the parse or the code for the parse tree from the grammar files. And then I'm gonna try to create a graph from the grammar. That's probably the it is the stuff that I'm more interested on, I think, now. So like try to create the graph structure from the grammar to visualize how string inputs become parse trees based on grammar rules, and then maybe I can find different grammar rules and see the differences in trees and compare them. But it would be nice if I could figure this out, so I clarify. But I think what I'm gonna have to do is just write down the main structs for each thing, and then follow the execution again and see how the functions are changing the data on the struct. It's probably the only way. Maybe I should search as well on how to. The problem is that it's on C and I try to use GDB. Like, I think I'm gonna waste too much time if I try to search for how to step over the code. Just like try to print stuff and see what is going on. It would be like helpful, I think. So looks like it sets up this config here and then it just copies here the py runtime for config. Then it returns. So it's just writing the config to the runtime. I think what's making this kind of confusing is that the runtime is a global variable, and then all of these other functions are going to change the global variable. So it's kind of hard to keep track of what's going on, but I think I'm understanding now. So let me think about... like, initially what I wanted to see, which is still not very clear to me, is at what moment does the... I think the thread is on... I don't remember if it's like... Yeah, I think it's here. So it connects the thread with the runtime, but it's kind of confusing still, like this, the main like interpreter here. But maybe it just initializes this automatically when it initializes the runtime. Like this already has the interpreter here, and then this just connects the thread, initializes the thread of this one here, like this function. It's probably that's what's happening. So if it's not initialized, then it runs this, and if it is, it reconfigures. So I guess this is the function that initializes the thread state. Yeah, Python create interpreter. So yeah, I think that it is clear now in my mind. So this is the one. But maybe I forgot to put this one there on the thing. I created. I think I forgot here. Maybe I skipped over this. Yeah, so this one, I think is, yeah, I'm not really sure now. No, it is from here, so I probably forgot to put here. So maybe I should just mark this down. I think I'm not gonna continue though, because it's probably not gonna... Like, the thing that I have to figure out is how to create this graph programmatically, and also like how to set up things in a way that allows me to get the... The main thing that I have to figure out is how to highlight show how data changes based on the flow of the code. But the challenge is that the data is going to be different depending on which program it is. So I have to figure out, like, how do I make this distinction when I'm parsing the code? Like, what is the data and what is the instructions? That's the challenge. Because essentially they are the same thing, so it's very, like, I have to spend time thinking about it to clarify this relationship. It looks like this is probably the thing that would be the highest return on investment. So if I could, like, create a program that shows the structs in the beginning and then creates the graph and allows me to step over the functions and then see how the struct changes, how the data changes with that. So like one way that I can imagine this is that if I put like an IDE space on the side of the graph, and then on the IDE I show the data, but then how do I define what the data is? That's the problem. Maybe I can, like, the thing is, yeah, if I manage to do it so I don't execute the code, then I think I can leave up to the user to define. So if I could do that, so for example, I can just type the name, and then you would select the struct. I think that's probably the best idea. So like I can put, let's say like this is the inputs on the website, then I can make it so that here is gonna show whatever, like, user puts like a pattern here, and then it searches for that pattern in the code and see if there's any data structures that are related to that. Then if there are, I display them on the text on the div. But then how would I see, like, how does it change? Because I would have to track the name, so it will probably be like I have to use the symbol table, I think. And based on the symbol table, but I think that's probably not the best, because like this is already a consequence. I have to clarify the relationship that I was talking about in the beginning, which is how different grammars become different parse trees. I think that's the most fundamental. Like first I need to clarify the whole compilation process. Then from the compilation process I can focus on the other stuff, because the distinction is gonna be somewhere along the fundamental nature of the compilation. And I think the main fundamental thing I think that I have to figure out is the grammar. That seems to be the main like thing here. Because the grammar is gonna create the data structures from the symbols, which are the keywords of the language. So like the sentences become keywords through a data structure that is the grammar. And highlighting things, like the definition of things, is gonna depend on this relationship of the semantics of the grammar, I think. The synthetic analysis. So if I need to clarify first the synthetic analysis, then like become really good at that first. Then once I figure that out, then I can go back to this, because I think that figuring out the secret to the distinction between data and the commands is gonna be some relationship on the grammar itself. So I have to study more that first, I think. And after that, I can figure out like how to use whatever I built, the visualizations from the grammar and the parse trees, to capture this, like how data changes across the code. Yeah, I think that's probably the best path. So I have to study this one manually, I think, to understand. Yeah, but I figure out. I think it's getting more clear in my mind. So the main inits, if I initialize from config, I have to remember how I got to this function. But this is the one that is going to initialize the interpreter, which is the struct there inside of the runtime environment. And then this one is gonna have the main thread inside, and then the main thread is gonna have the config, I think, or this other interp. The interp is gonna have the config. So it's just a linked list. Yeah, so that function initializes this thing, and this thing is gonna have the thread state is gonna be inside of this one, I think. This is gonna be a value of this other struct here. It's gonna be here. And this is gonna have the other interp, which is gonna have the config. Maybe not. Oh, here. I don't really know. Don't know which one is which. The configuration is directly on the interpreter. Why is it passing this one? It's not using. It's kind of confusing as well. I don't understand why it's passing this. It's not using. But I think this one is the one that creates the link between the two. So here's the link. And then this one is used to set up the values of the other one and then returns the other one. Interpreter sounds inter. So it sets up the head of this one to be equal to this one. So this head here is gonna point to the, it's gonna be equal to the one that initializes there. So I guess that's the link between the runtime state and the interpreter. It happens on this function here. And then this interp is gonna have the what is the relationship between this and the thread? So we attach this the main configuration to this configuration here. So like it's runtime states, then it has the interpreters, which is the yeah, the main interpreter is gonna be this one. This is equal to this, and then it copies this configuration on the configuration of this one. But where is the? Oh, so here probably. So the thread is gonna be a value of this one. So I think now it makes sense in my mind. It's just confusing because these structs have a bunch of different values and all these functions initializing everything. Yeah, so I guess that this is the function that initializes the thread state inside of the interp, which is the value of the runtime states. There's only one runtime because it has the flag variable that gets becomes 1 after the first time that the function is called. The other ones are probably to check to see if the runtime was initialized. If it wasn't, then it throws an error. But there's only one runtime that is initialized, which is the global thing. Then the interpreter of the runtime gets initialized on that function. And then on this function here, initializes the thread state from the interpreter. And the main configuration is going to be inside of this interpreter here, which is the other configuration there. And then inside of the configuration on the other functions there that have the macro, it initializes the file name. So the file name is inside of we have the Py runtime. inside of the runtime, you have this interpreter, and this interpreter has the configuration. And then inside of the config, you have the file name, which is, yeah, run file name here. And then it's probably going to use this run file name on these functions here. And on this function, it probably creates a file object on one of these from the file name inside of the config, inside of the struct. I think that's the reason why. So I'm gonna have to investigate these functions here again to see, like, now that I know which, because the first time that I was doing this stuff, obviously I wasn't paying attention to the structs because there's too much stuff to think about. I was just trying to find the relationship between the functions. But now that I know that the file name is going to be inside of this configuration here, I can just look at these functions again and try to see how does it create a file from the file name, and then what is going to be, like, it's probably going to be a file. The file object is going to be the property inside of one of these structs, and then it's going to use that property or the attribute of the struct to create the lexer, the tokens. It's probably going to happen somewhere here on these functions here. And then once it does that, it's going to call a bunch of different functions from the, depending which kind of thing you're running. Which is on this other part here. Yeah, this here. In this case, I just wrote down the py file, I think. The run file. But there's other ones. I think I wrote down, yeah. So it runs the file here based on the choices there. If you're running, like, I think most of the time you're just going to be running a script or a file that's going to be the main file for software. So that's going to be the case most of the time. It's going to run the file. Then on this one, it has several different options of different things you can run, I think. Yeah, here. So you have the file rule, the eval rule, the func rule, and the fstring. And I think that most of the times it's going to be this one. And at this point, it starts generating the abstract syntax tree based on the parser functions that were generated based on the pgen, which is the generator program that uses the grammar file to create the parse tree. And the parse, like, the Python functions there for the other thing, like these Python functions, uses the meta grammar to create the other grammar file and to create the files, the C files that have all the code for this parser file here. Like, the parser file itself is generated by these functions here by using the grammar file. And then from these parser functions, it has several different rules here, like these functions here, and these expression rules and interactive rules and whatever. And those are the rules that is going to use to build the tree from the tokens. Yeah, so I think now I have to, and here obviously there's the functions that create the tokens here as well. But I think that the file, it creates the tokens based on the file object here. So it's probably on these functions. I have to see these functions based on this thing here. But I'm gonna spend more time clarifying this thing here as well. Like, where does this, what exactly is the relationship? Because it's very confusing because there's multiple different things here. You can use multiple different threads. I think that's the part that is confusing me. And there's multiple different interpreter states as well. So I need to clarify a little bit more, but pretty confident now that this is the place that the file name is going to be, and it's probably going to use this set of these functions to create the file object. So I have to see these functions, to understand how it creates the file object, and then once I understand how it creates the file object, I can understand how it's going to convert the file object into tokens. It's probably going to be with these files here. This one. It's probably this function here. Tokenizer from file. I think I'm not gonna write the article though. I'm just gonna, because it's gonna take too much time. So I'm just gonna focus on trying to clarify, and after that, once it's clear, then I'm gonna focus on the Python code here. I'm trying to create the grammar from the code, or create the parser code from this code. I probably have to study the other syntax as well, like this language here, which is the one that is used to create the grammar. So I need to clarify more this language here, and then study the code to understand how the code creates the parser code from the language. That's the next thing that I'm gonna do after I clarify this stuff here. Yeah, but it looks like this is gonna create the thread, and then it links the thread to this thing. And this one is the one that was initialized there, I think. Is this one here, the interp, that was initialized on some of the other functions. So I guess when setting up the GUI here, in eating the GUI, which is the lock for the thread, it does the connection here of the threads. The interpreter, which is the same one from the thread, like, is the same one, I think. Oh, but it's saying that it's different here, so not really sure. It's still kind of confusing. It's becoming more clear on my mind, but I'm still confused. I think I'm gonna stop here. I'm already tired. I'm gonna watch a bunch of videos, and then, like, there's several different papers that I need to read as well. And I think I'm gonna try to see, like, the problem is that I didn't find any article that goes in depth into the details. Like, they all talk about the surface, like the concept level, but don't explain the code. But maybe some of the other ones do, and I forgot, like these ones. So I guess I'm gonna open them again and see if any of them talk about this stuff. The thing is, like, a lot of them are for older versions as well. That's the problem. So I think that probably the only way is gonna be to, like, look at the source code several more times. It's gonna take time. I think there's nothing I can do. So just read the documentation again, and then read all these papers, and keep looking at the source code until I understand how it works. It's probably what I'm gonna do. But probably next time that I stream, I'm going to work on this code here from the other project. Just copy the grammar files and then try to generate the parser code from this thing here and study this code to understand how it works. Because the main thing that I'm interested on is learning how to get, like, the grammar language from a file and then use that to create a parse tree from the code. And that's the most interesting to me, and then try to create a graph visualization out of that. Because if I have that, then I can test to see how several different grammars are gonna be different from each other, and I think this is gonna highlight the relationship between languages. Because all that a language is a way to encapsulate data structures into concepts, which is symbols, through this data structure, through the tree data structure. And the differences between languages are gonna be how they do that. It's gonna be the tree data structure that they create, because at the bottom they're all gonna be the same assembly instructions depending on which architecture it is. So the goal is to see if I can find or visualize how the different data structures, like how the different programming languages become the same assembly instructions, and the differences in the data structures that are created in the process, to see like what is the fundamental difference between them. So it's probably gonna take a lot of time for me to study all of this stuff. I'm not really sure when I'm gonna come back, but when I do, I'm probably gonna study this. And then off stream, I'm just gonna continue to look at the source code here, try to understand what the hell is going on, and maybe watch the videos again. So I'm not really sure when I'm gonna come back, but I'm gonna continue to do this. So see you next time.